Nice to see you. I'm Khatar Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain AS Chemistry Paper 1, Feb March 2023 1-2 variant. Let's get started. Question number 1. 4 equations representing reaction of nitrogen and one of the compound are given. Which equation represents a disproportionation reaction? First of all, what is the disproportionation reaction? A reaction in which same element or the one element is going to oxidize as well as reduced, or a reaction in which the same compound, the one portion of a compound is going to oxidize and the other portion of the same compound is going to reduce. So this equation, this reaction is about redox reaction, a special redox reaction that is having unique mechanism of oxidation and reduction. Same oxidizing agent and same reducing agents are over here. Same species are acting as oxidizing agent and same species are going to behave as a reducing agent. Let me check these 4 options turn by turn. Number 1, HNO3 plus calcium carbonate goes to calcium nitrate, CO2, H2O. In this case, HNO3, this nitrogen is having plus 5 oxidation state. How can we find the oxidation state? I'm putting the oxidation number of oxygen and hydrogen. For example, 1 oxygen is equal to -2. Here are 3 oxygen, so I'm putting -6 over here. Hydrogen is having fixed oxidation state that is +1, so I'm writing +1 over here. I'm ignoring this 2. I'm not counting the number of mole at the moment. So this HNO3 is having nitrogen and this nitrogen's oxidation state is +5. Now come to the next one. There is only 1 nitrogen and again this nitrogen is also having +5 oxidation state. How will you get to know? Basically, these both are nitrates. It's NO3. Here is again NO3. So if the similar species are present on the both side, it means that there is no change in oxidation state of these element or of these species. So there is no change in the oxidation state of nitrogen. Same is the case with the calcium. Calcium is having +2 oxidation state in this case. And how it is having +2? Calcium NO3 twice. 1 nitrate ion is having overall -1 oxidation state. In this case, there are 2 nitrate ions, so -2 over here. And to make the sum equal to 0, calcium will be equal to +2. So come towards calcium carbonate now. In calcium carbonate, once again, you will have to remember that the carbonate, the whole carbonate group is having -2 oxidation state or -2 charge. That is one and the same thing. So -2 over here and +2 over here. So there is no change in the oxidation state of calcium as well. Same is the case with the hydrogen. Same is the case with the oxygen. The first reaction, A reaction, is not a redox reaction. As I have told you, disproportionation reactions are the special redox reactions. Come toward this one. Nitrogen is having 0. Hydrogen is also having 0 oxidation state. And in this case, nitrogen is having -3 and hydrogen is having +3. So yes, this is a redox reaction, but it is not a special redox reaction in which there is no, the same species is going to reduce or oxidize. So B is also incorrect option. The second one, the third one, C option, ammonium chloride, sodium hydroxide is going to make NH3, NaCl, and H2O. This is some sort of acid-base reaction, you can say. And once again, in this reaction, there is no change in the oxidation state of nitrogen, hydrogen, chlorine, sodium, and so on. Each and every element is having the same oxidation state. This is not the redox reaction. However, only one option is left. Obviously, it will be the correct option. And how it is, let's see over here. In this case, here is NO2 And in this case, oxygen is equal to -4, so nitrogen is equal to +4. Initial oxidation state of the nitrogen is +4. I'm going to jump towards these two nitrogen species. In this case, as we have seen that the nitrogen is having +5 oxidation state in case of HNO3. So HNO3, in HNO3 or wherever there is NO3, the oxidation number is +5. And in case of HNO2, we can find the oxidation state of nitrogen -4, +1, and here it is +3 to make the sum equal to 0. So the nitrogen is going to oxidize in this case. It is increasing its oxidation number. And in this case, it is going to reduce. So the same species, same element, nitrogen, once it's going to oxidize and then it's going to reduce itself as well. So this D is the correct option. It is disproportionation reaction. Question number 2, the diagram shows Boltzmann distribution for 1 of the mole of the gas. The gas take part in the reaction with an activation energy. Basically, this graph is given over here. You can see that number of particles is lying on y-axis, energy is lying on x-axis. This is the mark for the line of borderline for the energy of activation, and this curve is basically said to be or known as P. Which statement correctly describe the effect and increase in temperature? So by increasing the temperature, what happened to this curve? I'm going to draw a rough curve, the rough shape of this new shape of this curve that is almost like that. What is happening basically? Its height is going to shift on the right hand side, and it is also decreasing its height. And there is more population of the molecule having energy more than energy of activation. So which one is the correct option? Which statement correctly describe the effect of an increase in temperature? A option, peak P will be higher. No, it will be lower in height. So peak P will be lower. Higher options are incorrect options. Peak P will be lower. Yes, it will be lower. The next portion is fewer molecule will have high energy than energy of activation, and more molecules will have high energy than energy of activation. So more molecules are now having high energy than energy of activation. So there is now increase in the amount of population of molecule. Those are having high energy than the energy of activation. So D is the correct option. D is the correct option. Question number 3. A student carries out 4 experiments to investigate the rate of reaction between 3 grams of calcium carbonate and hydrochloric acid. Calcium carbonate plus HCl goes to CaCl2 plus CO2 plus H2O and so on. Experiment 1, 2, 3 and 4. Calcium carbonate powder plus 2 mole per dm cube HCl at 35 degrees Celsius. Similarly, the experiment 2, calcium carbonate powder, 2 mole per dm cube HCl at same temperature 35 degrees Celsius. Experiment 3, large lumps of calcium carbonate plus 1 mole per dm cube HCl at room temperature. Experiment 4, large lumps of calcium carbonate 1 mole per dm cube HCl and 35 degrees Celsius is the temperature. The student collects CO2 and the time how long it takes to produce the same volume of the gas for each experiment. What would be the correct times for the 4 experiments? Option A, B, C and D. First of all, you can see that I'm starting from experiment number 3. In this experiment, there are large lumps. Those are going to decrease the rate of reaction. Comparatively, the concentration of HCl is also half, but it's again going to decrease the rate of chemical reaction, and temperature is also less. Room temperature, that is approximately 25 degrees Celsius. So all the factors are basically indicating the low rate of reaction. I mean, the time taken will be higher. Time taken will be higher. So I'm choosing the highest time in this column for experiment 3. Now come towards experiment 4. In this case, again, the same calcium carbonate, large lumps are over here and same concentration of HCl, but this time temperature is higher than that of room temperature. So this experiment 4 should be completed in less time interval as compared to the experiment number 3. So the less time as compared to the, you can say experiment number 3, it will be almost 30, or you can say 10. Moreover, it is more, expected that its time will be the 30th one, 32nd, and so on. Now come toward question, experiment number 2. Calcium carbonate powder plus 2 mole of HCl is a powder, 2 mole per dm cube concentration, and the temperature is also higher one. So the experiment 2 is going to have less time. Its speed will be higher as compared to experiment 3, experiment number 4, it will be higher. So obviously we are basically choosing B or C lines. So it is highly expected. And so, we can conclude from this data, the B is the correct option. B is the appropriate option. However, I'm not convinced with the experiment 1 and 2 data or the result of experiment number 1 and 2, because there are quite pretty similar, same conditions. Calcium carbonate powder, 2 mole per dm cube HCl, 2 mole per dm cube HCl, same temperature. So as far as my opinion is concerned, these two columns should have the same number. However, we can assess that, we can conclude that B is the correct option from rest of the data. Question number 4, the table shows the partial pressure in the equilibrium mixture formed by Haber process. Here is the Haber process. Substance, partial pressures are given over here. If the equilibrium mixture is asked, or that is announced, and you are having the partial pressure, then the simplest way is, or the easiest method is, just first of all, I'm going to write the expression of Kp as he is saying to calculate the equilibrium constant. So Kp is equal to, from this balanced chemical equation, that is the pressure of NH3 square divided by the pressure of hydrogen raised to power 3, pressure of nitrogen raised to power 1. So the pressure of, as I'm going to find the Kp, so I'm putting these values, partial pressures at equilibrium. What is the partial pressure of ammonia? That is 4,000. 4,000 raised to power 2 divided by 1,000 raised to power 1, that is nitrogen's partial pressure, and hydrogen is 8,000 raised to power raised to power 3. So the Kp is equal to 4.5 into 10 to the power minus 9. A is the correct option. A is the correct option. Question number 5, a reversible reaction is shown over here. Delta H is equal to plus 77 kilojoules per mole, which change in condition will move the position of equilibrium towards right hand side or towards right and increase the value of equilibrium constant. Equilibrium constant is going to increase, and the next thing is it's moving towards the right hand side. This is the right hand side and this is the left hand side of the equation. One thing, only one parameter can change, can increase, can decrease the value of equilibrium constant, that is temperature. So I'm shortlisting my options. So there is any sort of effect of temperature. So this reaction is endothermic. If I want to move this reaction, this equilibrium toward the right hand side, so higher temperature is required. So increasing the temperature, endothermic side is favored. By increasing the temperature, equilibrium will be shifted towards the right hand side. And the second thing is, yes, increase in temperature will also change the answer of equilibrium constant. So increase in temperature will shift the equilibrium position, as well as it will increase the answer of Kc or Kp. So D is the correct option. Question number 6. The ore silomelane may be considered to have general formula. This one. In this general formula, X positive and Y positive are the two different oxidation states of manganese. In this silomelane, what could be the value of X and Y? The basic thing is, once again, the basic parameters or the easiest way is the whole oxidation state of all these elements must be equal to 0. It's a neutral compound. It's a normal formula, you can say, and its oxidation state, the sum of oxidation state must be equal to 0. Here is OH group that is having one OH is equal to -1, and there are 4 OH group, so -4 over here. In this case, here is oxygen that is -2. One oxygen is equal to -2. 16 oxygens are there, so there is -32. Oxidation number of oxygen. What about barium? Barium belongs to group number 2, so its answer is +2. So what should be the answer of X and Y? That the sum of all these boxes must be equal to 0. So I'm trying option number 1. If I'm putting X is equal to 2 and Y is equal to 4. So X is equal to 2 mean +2 or 2 plus you can say, and 4 if Y is equal to 4, 8 fours are 32 plus 32. So what will be the overall answer? Yes, the answer is equal to 0. The sum of these all boxes is going to be equal to 0. So yes, these are the correct options. So X is equal to 2 and Y is equal to 4, and A is the correct option. A is the correct option. Question number 7. Silicon react with a mixture of calcium oxide and magnesium oxide at 1200 degrees Celsius. Magnesium oxide plus calcium oxide plus silicon goes to 2 mole of magnesium and calcium silicon tetroxide, you can say. The statement about the reaction is correct. Calcium is reduced, silicon is neither oxidized or reduced, magnesium is reduced, calcium is neither oxidized or reduced, magnesium is reduced, silicon. I mean, this is once again a redox reaction or redox question about the redox reaction. So first of all, I'm going to check the change in oxidation state of these elements. In this case, magnesium is +2, you know, is having the fixed oxidation number as it belongs to group number 2. Oxygen is equal to -2. In case of calcium, again, it's group number 2 +2, -2 for oxygen. Silicon alone, 0. Again, magnesium is the pure element in this case. It's alone, its oxidation number will be 0. And here is silicon, calcium, silicon, and oxygen. 3 elements are lying over here. Calcium never changes its oxidation state. It's going to have once again 2 oxidation state. So 2 calcium mean +4 over here. Oxygen is equal to -2. -2 into 4, -8. To make sum is equal to 0, I'm putting +4 over here. So silicon is showing +4 oxidation number. What is happening? What is changing basically? Magnesium is changing its from +2 to 0. Silicon is changing from 0 to +4. But there is no change in oxidation state of calcium. 1 calcium is equal to +2. Again, 2 calcium is equal to +4. And 1 calcium will be obviously equal to +2. So there is no change in calcium oxidation number. No change in oxidation state of oxygen. Magnesium and silicons are changing their oxidation state only in the whole this reaction. So what is happening to the magnesium? Magnesium is basically reducing itself. There is reducing or reduction, and what is happening to the silicon? It's oxidizing, or oxidation is over here. So silicon is going to oxidize itself. Magnesium is going to reduce itself. So which one is the correct option? Magnesium is reduced. Calcium is neither oxidized or not reduced. Yet this is true. And calcium is reduced, no. And once again, let me confirm the option C. Magnesium is reduced, yes. Silicon is neither, no, it is going to oxidize. Silicon is reduced, no, it is going to oxidize. So it is confirmed that B is the correct confirmed answer. Question number 8, in which species is there a lone pair of electron? So I am going to draw the Lewis structure for each option. CH3, carbon, hydrogen, hydrogen, hydrogen. You know, carbon is having 4 outer shell electron. At the moment, it seems that it is using only 3 electron. 1 electron is left behind on its last shell. It's a radical, you can see. Ca3 positive, it is also having the similar structure, 1 positive ion, and hydrogen, hydrogen, 3 electron are used by this carbon, each, 1 electron by hydrogen, and there is no lone pair. In case of CH3 negative, 1 carbon, 3 hydrogen, and this negative charge, this is the negative charge. Negative charge can be written as in form of a lone pair. Yes, it is true. C is the correct option. However, I'm going to draw the methane as well. CH4, this CH4, carbon is utilizing all its 4 electrons. So there is no any sort of lone pair present on the carbon atom. So C is the confirmed answer. Question number 9. Under this condition, will nitrogen behave most like an ideal gas? For ideal behavior, temperature must be higher and pressure must be lower. Temperature should be higher and pressure should be lower. So higher, lower, B is the correct option. B is the correct option. Question number 10. The equation for the chemical reaction is shown. All substances in their standard states. Xenon hexafluoride, plus 3H2, xenon oxide plus HF. Which statement describes the standard enthalpy change of reaction for this reaction? Basically, what is the basic name of enthalpy change of this reaction? We can call it enthalpy change of 1 mole of xenon fluoride. Yes, it is true. It is the enthalpy change of reaction of 3 mole of water. Yes, you can say. Or it is enthalpy change of when 1 mole of Z oxide or xenon oxide is going to be formed, or 6 mole of HF, and so on. So let me check the option. Enthalpy change when total 1 mole of product is produced. No. Basically 7 moles are products are lying over here. Enthalpy change, a total 1 mole of reactant is reacted. No. 4 moles are going to react. Enthalpy change when 1 mole of water is reacts. No. 3 mole react. In this case, again, these all first 3 options are incorrect. And enthalpy change when 6 mole of hydrogen fluoride are produced. Yes, it is true. This reaction can be considered as the enthalpy change with respect to 6 mole of enthalpy, 6 mole of HF, not the formation of HF. This enthalpy change is with respect to the 6 HF. Yes, you can say 6 mole of HFs are produced or formed, you can say. But this is not the enthalpy of formation. D is the correct option. Question number 11. Molten aluminium chloride has a simple molecular structure. Each molecule consists of 2 aluminium and 6 chlorine atoms. It is Al2Cl6. Which statement is correct? A, B, C, D. All chlorine atoms in 1 gram molten aluminium chloride have the same mass. Answer is no. Because there are 6 chlorine atoms and there are 2 type of Cl isotope. Cl35, Cl may be of 37 mass. So there are different isotopic abundance of the Cl. So not the all chlorine must be having the same mass. B, 1 mole of molten. 1 mole of molten aluminium chloride contain 6.02 into 10 to the power 23 aluminium atoms. Basically, 1 mole of aluminium chloride is having 2 mole of aluminium atoms. So the aluminium atom in 1 mole of Al2Cl6, aluminium atom is equal to 2 moles. 2 mole of aluminium atoms mean number of atom 2 moles into 6.02 into 10 raised to the power 23. I mean that will be doubled. So it is again incorrect option. It must be equal to this one. Right? See, 1 mole of molten aluminium chloride contains 3.61 into 10 to the power 24 chlorine atoms. 1 mole is having 6 moles of chlorine atom. 1 mole of Al2Cl6 is having 6 moles of chlorine atom. How to find an atom? 6 moles into 6.02 into 10 raised to the power 23, I mean Avogadro's number. And yes, that is equal to 3.61 into 10 raised to the power 24. C is the correct option. 1 mole of aluminium chloride, that is having the formula Al2Cl6, is having these number of total chlorine atoms. Yes, it is true. Question number 12. Which atom contains 4 times as many neutron as the lithium atom? What is the neutron number in the lithium atom? 7 minus 3, that is equal to 4. And he is saying basically 4 times, 4 4s are 16. So which one species having 16 neutrons? Here is 20 neutron, 40 minus 20. Here is 12 neutron. And here is 16 neutron. Yes, so C is the correct option. Question number 13, which statement about the first ionization energies of the magnesium and neon is correct? Magnesium and neon, basically, the first thing is ionization energy is always endothermic. Ionization energy is always endothermic. The second thing is we are going to compare magnesium and neon. So basically, neon that is having stable octet, I mean it's a noble gas and it is having stable electronic configuration, so it will retaliate whenever you are going to whenever you are going to remove electron from its last shell. Moreover, it is having more atomic number, more nucleus attraction and so on. So the neon is having more first ionization energy. First thing. Magnesium is having greater numerical value. No. Magnesium is having greater numerical value. No. Neon is having greater numerical value. Yes. Neon is having greater numerical value. Yes. Now come to the second portion. I mean, both are endothermic. Yes. Both are exothermic. No. Ionization energy is always endothermic. So C is the correct option. Question number 14. In a sample of pure water, what is the maximum number of hydrogen bonds that one molecule of water can be involved? Basically, H2O, one molecule of H2O is having 2 lone pair on oxygen atom. They can participate in the hydrogen bonding. Similarly, 2 partial positive hydrogen, they can also participate in hydrogen bonding. So basically total 4 hydrogen bonds can be made by 1 water molecule. So D is the correct option. Question number 15. Hydrated cobalt 2 sulfate loses water when heated to give anhydrous cobalt 2 sulfate. All water of crystallization is lost to the atmosphere as a steam when 3.10 gram of hydrated cobalt sulfate .xH2 is heated to the constant mass. The loss in mass is 1.39. This loss in mass is the mass of water, right? So the next one, what is the value of X to the nearest whole number? First of all, what is the basically mass of, what was the mass of cobalt sulfate in that compound? That is 3.10 minus 1.39. That is the mass of cobalt. That is the mass of cobalt. Let me check it over here. That is 1.71 gram. So the mass of cobalt sulfate is 1.71 and mass of water is 1.39. I'm going to apply the basic steps of empirical formula. So 1.71 cobalt sulfate and 1.39 water. Cobalt sulfate versus H2O. I'm going to make the empirical formula of these two species. I'm using MR this time, but I'm applying the same step as that of empirical formula. In this case, we are having the mass 1.71 gram of cobalt sulfate and 1.39 of H2O. 1.39 of H2O. Okay, now it is divided by its MR. MR is equal to 59 plus 96 and its MR is equal to 18. In this case, you can see that what is the answer? Let me check. Let me find the answer of these expressions. 1.39 divided by 18. The answer is 0.077. What about this one? 1.71 divided by 59 plus 96. The answer is 0.011. Now I'm going to divide by the smallest answer on both sides. I mean 0.011, 0.011, and here is 1:7. So when 1 mole of cobalt sulfate is over here, then there will be 7 mole of H2O. So X is equal to 7. X is equal to 7. I'm marking C. C is the correct option. Question number 16, table shows the bond energies. For some diatomic molecules, deuterium is an isotope of hydrogen and so on. Which statements are correct? Diatomic molecules have exact value for their bond energies, which are always positive. Yes, it is true. Basically, the diatomic molecule is having only one atmosphere. They cannot be used in multiple atmosphere in multiple scenarios. So their bond energy is said to be the real bond energy, exact bond energy, and so on. And bond energy is taken as a positive enthalpy. Yes, it is true. It is always positive. So one option is the correct option. The 0.210 in group 7 bond energies can be explained by the variation in instantaneous dipole dash induced dipole forces. No. These forces are going to show the physical properties, physical forces between the molecules. And the bond energies are basically measured as the true chemical bond strength. I mean, these are the true chemical bond energies, so they have no relationship with these intermolecular forces, so D2 is incorrect. Values for enthalpy change for the reaction between deuterium and chlorine can be calculated using these data. No, we cannot calculate it just using these data. Yes, we cannot. The reason is, for example, if I'm going to react DD with Cl2, chlorine CClCl, obviously they are going to make DCl, 2 mole of DCl. So to make to find the answer of delta H, we need the bond energy of DCl. There is no any bond data of DCl present. So the third one option again incorrect. One only, I mean A is the correct option. Question number 17. Two procedures are described. Sulfur is burned in excess oxygen, then NO is added to the product mixture. Number 1. Number 2, sulfur is burned in excess oxygen, then NO2 is added to the product mixture. Which procedure will produce some sulfur trioxide? Basically, sulfur dioxide. Once sulfur is roasted with oxygen, it is going to make SO2. then NO is allowed to react with it, or then when NO2 is allowed to react with it, there is a redox reaction basically. Yes, NO and SO2 can meet together to make SO3. Sulfur trioxide formation will take place. It's possible, yes, it is true. Same is the case with NO2, and there is the formation of SO3 as well. So in both cases, sulfur dioxide can be changed into sulfur trioxide. In both cases, I mean A is the correct option. Question number 18. Powdered P is a mixture containing 2 of AgCl, AgBr, or AgI. P is shaken with dilute aqueous ammonia. A yellow solid Q remains. So you know that its color is white, its color is off-white, and the color of AgI is yellow. So it means that one of the component is AgI. That's why the solid Q remains, yellow solid remain, and so on. The mixture is filtered and Q is washed and dried. The filtrate is cooled and treated with aqueous nitric acid to produce a white precipitate. I mean, filtrate is then basically the mixture is filtered, Q is washed and dried. The filtrate is cooled and treated with aqueous nitric acid to produce white precipitate back. The purpose of this nitric acid, the reaction of this nitric acid is to neutralize the aqueous ammonia present in the solution. So this is the reversal of first step. Again, it's going to make white precipitate. White precipitate belongs to AgCl, which is filtered off, washed and dried. Q and I are formed separately with a concentrated sulfuric acid. Now, what is the Q? Q is basically AgI. What is the R? R is most probably AgCl. So, when AgI is allowed to react with a concentrated sulfuric acid, finally white fumes are formed. Whenever any solid compound that is having halide ion, iodide ion, especially when it is allowed to react with a concentrated sulfuric acid, there is a formation of iodine, so white fumes may be observed. What is happening when the Cl negative ion as a halide ion is allowed to react when concentrated sulfuric acid? Then only steamy or misty fumes are formed. So only steamy fumes are formed. There is no further reaction. So B is the correct option. B is the correct option. Question number 19. Two periods, 3 elements, X and Y, burn separately in oxygen to form solid oxide. Period 3 elements. There are 2 period 3 elements. One is, let's suppose, X, other one is, let's suppose, Y. Oxide of X is insoluble in water. Oxide of Y dissolve in water to form solution which dissolve the oxide of X. Oxide of X is insoluble in water. In the list of period 3 element, whose oxide is insoluble? It may be aluminium oxide, it may be silicon oxide. So, aluminium or silicon oxide may be the X. The oxide of the Y dissolve in water, and it's going to dissolve the oxide of X. If I'm going to dissolve sodium, it's going to make sodium hydroxide into the water. If I'm going to dissolve phosphorus, it's going to make phosphoric acid into the water, let's suppose. Sulfur oxide are going to make sulfuric acid or sulfurous acid, you can say that. Oxide of phosphorus are going to suppose to make phosphoric acid or phosphorus acid, same as the case with sulfur oxides. So, the silicon oxide is also an acidic oxide. So, silicon oxide cannot be dissolved in H2SO4. Silicon oxide cannot be dissolved into the H3PO4, phosphorus or phosphoric acid, because they both are acidic oxides, or they both are acids basically. Aluminium oxide may be dissolved into the sodium hydroxide. Yes, it is true, because aluminium oxide is an amphoteric species. So A is the correct option. Aluminium oxide can be dissolved in the solution of oxide of X. Yes, it is true. Because Al2O3, aluminum oxide, is an amphoteric. It can react with acid as well as base. So 19A is the correct option. Question number 20. Which row describes the structure and bonding of SiO2 and SiCl4? You know, SiO2 is a macromolecule. SiCl4 is a simple covalent molecule. So very much simple question, quite simple question. You can say structure is joint for SiO2, nature of the bonding is covalent, structure is simple, and nature of the bonding is covalent. So the middle line, I mean B option, is matching in all columns. B is the correct option. Question number 21. A sample containing 0.01 mole of anhydrous calcium nitrate is heated strongly until it fully decomposes. All the gas produced is collected and its volume measured at room temperature, at room conditions. What is the volume gas produced? Whenever you are going to heat group 2 nitrate, it's going to decompose into 3 components. 2 of them are the gases basically, and he is also saying about the gases. So when the group 2 nitrate, let's suppose 1 mole of group 2 nitrate is decomposed, basically 2.5 moles of gases are formed. I mean 2 mole of NO2 is formed and 0.5 mole of oxygen is formed. So 1 mole is going to give 2.5 mole of gases. And what about this one? If we are using 0.010 mole, then what will be the moles of the gases? Mole of the gases will be 0.01 multiplied by 2.5, that is equal to 0.025 moles. So the total moles of the gases in this reaction will be equal to 0.025 moles. To change into the volume at room temperature, I'm going to multiply it by 24,000. 1 mole of any gas at room temperature is having 24,000 centimeter cube. So multiply by 24,000 and the answer is 600. B is the correct option. B is the correct option. B is the correct option. V and C are the both element in the period 3 of the product table. Each element form one stable ion that does not contain any other element. I mean, alone simple ion of a metal V or Z, a simple metal ion you can say, or simple non-metallic ion you can say, simple element ion. Where is having atomic radius 0.186 and its ionic radius is less than that of its atomic radius. It means that it is making positive ion or it is having positive charge. In case of Z, the atomic radius is 0.099 and its ionic radius is higher, 0.181. So it is having negative charge. I mean, from this data, we can conclude that V is making positive charge, Z is making negative charge. Now come to the next one. Which statement is correct? Ions of V and Z have the same number of full electron shells. Whenever you are going to make the positive charge, positive ion, I mean, it means that you are losing some electrons. So there is chance to lose one shell or more than one shell. So their number of shell never become equal if they are two opposite ions. Positive ion, especially positive ion, may lose its electron as well as its last shell. Second one, ions of Z are positively charged. No, as we have checked it, it is the negatively charged. Z has greater electronegativity than V. Who is making negative charge? Z. So yes, it is true. An element that is having more tendency to gain electron, it is having to chance of making negative ion. Yes, it is true. C is the correct option. And let me check the D1. V has more outer electron than Z. No, it's not a correct. V is not having more outer electron. Basically, the species that is having more outer electron, that is going to have negative or that is having more possibility to gain the electron. So V is making positive ion, so it is not having more electron as that of Z, as it is going to prefer the lose electron. Question number 23. In group 2 of the product table, the properties of the element and their compounds show regular change down the group. Which properties show decrease from magnesium to barium down the group? Decomposition temperature of the carbonate, decomposition temperature of the nitrate, I mean thermal decomposition of the carbonate and nitrate, solubility of the hydroxide, solubility of the sulfate. 4 options are over here. As we move down the group, basically the decomposition temperature increases. More heat is required to decompose the carbonate. Same is the case for the nitrate. More heat is required to decompose the nitrate of group 2 element. I mean compounds are going to become more stable. So one incorrect, second incorrect. Solubility of the hydroxide also increases. The bottom hydroxide, I mean barium hydroxide, is more soluble, but solubility of the sulfate decreases. Barium sulfate is famous insoluble salt, so D is the correct option. Solubility of the sulfate decreases. Question number 24. 4 properties of the beryllium or the beryllium compound are listed over here. Which property is different from the property of magnesium or equivalent magnesium compound? A option, beryllium reacts with oxygen when heated in air, magnesium does not. No, magnesium also reacts with oxygen to make magnesium oxide. So one option, A option, is incorrect. Beryllium reacts with the aqueous H2SO4 to form a metal sulfate. Hydrogen, magnesium does not. No, magnesium also reacts with the sulfuric acid to make hydrogen and magnesium sulfate. BeNO3 decomposes on heating to form metal oxide, nitrogen dioxide, oxygen, but magnesium nitrate does not. No, magnesium nitrate also decomposes to give nitrogen dioxide to make oxygen and a metal oxide. The last one, BeCl2 react with water to form fume of HCl. MgCl2 does not. Yes, MgCl2 is not supposed to react with the water. BeCl2 react with water. Yes, it is true. But MgCl2 is not supposed to react with the water. So D is the correct option. Question number 25. Which two formulae correctly represent a pair of structural isomers? A option, and I'm going to draw the different structure of these different compounds. What are the structural isomers? First of all, isomers are the compounds having same molecular formula but different structure formula. In case 1, in option 1, I'm going to draw the formula, write the formula: CH3, CH, CH3, CH, C double bond OH. The next one is CH3, C, CH3, CH, C double bond OH. They are one and the same thing, both having same name, and the both name is 2-methyl propanoic acid. So one pair, the first option pair, is incorrect. They are not isomers. The second one, basically this one, I am going to draw the formula of the next one. CH3 and CH. Here there is C double bond OH and CH3. Once again, it's 2-methyl propanoic acid. And what about the next one? That is similar one. That is also, its name is also 2-methyl propanoic acid. So the best tool to check, to diagnose the isomerism is the nomenclature. Write the structure, give the name, and choose the isomers. I mean, this is also having the same name as I have drawn in first case. Come towards C. what is its name? It is basically C double bond OH, CH3, and I think this is an incorrect formula if I'm not wrong. Option C, first formula, this one, CH3, CH, C double bond O, OH, OOH. This is incorrect formula. First one is not correct, second one is not correct, third one formula is incorrect. Moreover, there are 4 carbon atoms and there are only 3 carbon atoms, I mean incorrect. So obviously D will be the correct option. However, I'm going to give the name, that is 1, 2, 3, 4, that is butanoic acid. Butanoic acid. And what is the name of this acid? That is having this one, 2-methyl propanoic acid. Similar one, that is 2-methyl propanoic acid. The next thing is 1, 2, 3, 4. 4 carbons are there. I mean same carbons. Hydrogen 6, 7 and 8. Same is the case. I mean 5, 8. Yes, 2 oxygen, 2 oxygen. In D option, all elements are same. Number of elements are same, but the structure is different. So yes, they are structural isomers. D is the correct option. Question number 26, which reagent and condition would result in the formation of butane nitrile? So how can we synthesize, how can we make butane nitrile? Let's see options turn by turn. 1-bromo butane heated under pressure with ammonia and ethanol. 1-bromo butane. 1-bromo butane. This is 1-bromo. The short test representation of 1-bromo butane. If I'm going to react it with ammonia, so the nitrogen will be over here, and this is called amine, and it is not having cyanide group basically, so it is incorrect option. Nitriles cannot be made in this way by the substitution of halogen by the amino group. No, this is not the way to synthesize the nitrile. The next one, 1-bromopropane heated with potassium cyanide and ethanol. Yes, if you are having 1-bromopropane, then by reacting with KCN, you are going to have CCC, older one C and new CN. Yes, we can synthesize this basically, that is butane nitrile in this route, and that is 1-bromopropane when it is heated, when it is reacted with potassium cyanide and ethanol. So basically B is the correct route, appropriate route, correct option, and so on. Question number 27. Compound X C7H13Br react with a hot alcoholic NaOH to produce 2 compounds Y and Z. One reaction with Br2, Y gives the product this one, which exists as a mixture of 4 optical isomers, mean there are 2 chiral centers. And in case of Z, that gives the product C7H12Br2, which is non-chiral. What X could be? First of all, the first step is basically, you can see it over here, C7H13Br react with the hot alcoholic NaOH to make 2 compound. What are these 2 compound Y and Z? These are 2 alkenes, right? What are these 2 alkene? I am going to start from option A. Let's see over here. If the 1 Br from this carbon and 1 hydrogen from this carbon, there is the loss of HBr, and we are going to have carbon-carbon double bond over here. We are going to have carbon-carbon double bond over here. And the second option is, if we are going to lose Br from here, and H from here. So the second loss of HBr is going to have double bond over here. So in this first option, I'm going to write over here once again. There are the two possibilities. One may be Y, one may be Z. I mean, one may be Y and one may be Z. Yes. In case A, in case of A, the first possible alkene that can be made, that is this one. I mean CH2 and overall this one, right? The next one, the next possible alkene that can be written as CH3 and double bond over here. That is the second possible one of, it may be called as Y and other one is Z. Now what is the Y? Y is going to react with Br2 to give the mixture of 4 optical isomer to give 2 chiral centers, and Z is not having any chiral center when it is allowed to react with bromine. So if I'm going to react it with bromine, if I'm going to react it with Br2, so double bond is again broken down, and here is one Br, here is the other Br. So let's see over here how many possible chiral centers are there. There is no chiral center. There is no chiral center. I mean, this carbon is not chiral because these cyclic group is similar on anti-clockwise and clockwise. I mean, there is no chiral center, no chiral center. So it could be Z. Yes, it is true. It could be Z that is having C7H12Br2 and it's non-chiral. So it is also having C7 and hydrogen is equal to 12, 2, 2, 2, 2, 2, 2, 2, 2. Yes, 12 hydrogens are there and it is C. If it is Y, then what should be the outcome when Br2 is added into this molecule? Plus Br2, I mean, and it's going to make CH3, Br, and Br. I mean, only one compound is possible over here, that is this one. And now this compound is having 2 chiral center. One hydrogen is over here, one chiral center is over here, and this carbon is also a chiral carbon. So yes, this Y is having 2 chiral carbons, and if it is having 2 chiral carbon, it is going to have 4 optical isomers. 4 optical isomers. Yes, it is true. So the A option is going to fulfill all these conditions, all these, I mean, fulfill the formulae that is given by the Y, that is given by the Z. All habits are quite similar as that of its description. And so A is the correct option. There is no need to check the other option. Question number 28, when illudine S is heated under reflux with excess of potassium dichromate 6, compound M is formed. You know what is the function of chromate? Potassium dichromate. That is an oxidizing agent, but it cannot oxidize carbon-carbon double bond. Carbon-carbon double bond will remain unchanged. It can oxidize primary alcohol, it can oxidize secondary alcohol, it cannot oxidize tertiary alcohol. So primary alcohol can be oxidized, secondary alcohol can be oxidized, but tertiary alcohol cannot be oxidized, double bond cannot be oxidized, and so on. So I'm going to make its oxidation. So this is carboxylic acid finally, as you are having excess heat under reflux. So this primary alcohol is going to change itself into carboxylic acid. What about this secondary alcohol? It's going to change itself into ketone. So this is the ketone. This is carboxylic acid. No other change is going to happen in this case. What is the molecular formula? 4 options are over here. All options are having same carbon, so there is no need to check the carbon atoms. All options are having different oxygen. Oxygen may be 4, maybe 5. So let me check the oxygen. 1, 2, 3, 4, 5. So either B or D may be the correct option. So the next one is to check the hydrogen atom. hydrogen. Hydrogen 1, 3 hydrogens, no hydrogen, 1 hydrogen, and basically no hydrogen, no hydrogen, 3 hydrogen, no hydrogen, no hydrogen, 3 hydrogen, 2 hydrogen, 2 hydrogen, and as you have seen, 1 hydrogen over here. So 1 3 1 3 3 2 2 3 3 and 1 16. So B is the correct option. B is the correct option. Question number 29. Cyclohexene C6H10 is a hydrocarbon with 6-member ring of the carbon atoms. It has several structure isomers that are state chain alkenes. The number of double bond in each of these molecules is P. So P is the number of double bond in the molecule that is having alkene, that are alkenes, they are not cycloalkenes, are cycloalkenes. What is the shape of cyclohexene molecule? Number 1, shape. And the second thing, what is the value of P? So basically, as we have seen that it is initially a cyclohexene. When we are going to change it into an open structure, then at least 2 double bond must be there. What is the formula of this cyclohexene? That is C6H10. So C6H10, C6, C6, and now H10. CH3, CH2, CH, 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 CH3, let's suppose. So I will have to put at least 2 double bond to make hydrogen is equal to 10. If I'm putting double bond over here, if let's suppose I'm putting double bond over here, so now the hydrogen is equal to 3, 4, 5, 6, 7 plus 3, 10, yes. So at least 2 double bond should be there to fulfill its formula, that is C6H10. So P is equal to 2. This molecule is having at least 2 double bond. What about its shape? Its shape is planar or non-planar. This is sp2 hybrid carbon. This is sp2 hybrid. This carbon is also linked with the sp2 hybrid. This carbon is also having the linkage with sp2 hybrid. So this portion of the molecule is lying in one plane. But you know, this carbon is sp3. It is not in the same plane. This carbon is sp3. Again, it is not lying in the same plane. So overall, this is non-planar structure. So D is the correct option. Overall, it's non-planar structure. D is the correct option. Question number 30. Exhaust gases from an internal combustion engine are made less harmful by passing them through a catalytic converter. A number of reactions take place in catalytic converter. 2 such reactions are described in the table. Which row is correct? The type of reaction that removes carbon monoxide. Carbon monoxide is changed into carbon dioxide. So what is the name of this reaction? That is oxidation. The type of reaction that removes unburned hydrocarbon, let's suppose, for example, unburned hydrocarbon is CH4. For example, let's suppose plus O2 goes to, plus O2 plus nitrogen, so on, goes to, finally carbon is changing into CO2 and hydrogen is changing into water. So once again carbon is going to oxidize, H is also going to oxidize, so again oxidation. So A is the correct option. 31. Which compound reacts most rapidly with aqueous silver nitrate by SN1 mechanism? Who is going to suppose to follow the SN1 mechanism? Tertiary haloalkane. Tertiary haloalkanes are supposed to give the reaction by SN1 mechanism. So which one is the tertiary haloalkane? Number 1. Number 2, most rapidly. There are basically two main things, two main portion of this question. Number 1, these are haloalkane. One is having chlorine. One type of haloalkane is having the CCl bond, and other one group is having Ci bond. Iodomethane or iodomethyl, I'm going to write the structure of this one. 1-chloromethyl propane. 1-chloro, this is the methyl propane, and here is Cl. 1-chloromethyl propane, CH2, CH, CH, and CH2. But this is not the tertiary haloalkene. The next one, 2-chloromethane. Yes, we can write it over here. This is the 2-chloromethane. Yes, it is tertiary haloalkane. So it may be the one of the correct options. Maybe the correct option. I mean, 1-iodo is not the tertiary. 1-chloro is not the tertiary. 2-iodo methyl propane. Again, it could be this one. It is this one. I mean, it not could be, it is this one. And you can see that. Which one is the weakest bond? CCl bond is weaker or the Ci bond is weaker? Obviously, Ci bond is the weaker bond, is going to give the rapid reaction, most rapid reaction. And yes, it is tertiary haloalkane as well. So D is the correct option, that is following the SN1 mechanism, and it is also given the rapid reactions. Question number 32. Tartaric acid, that is having acidic group OH, OH, and again the second acidic group, is found in many plants. A sample of tartaric acid react with an excess of lithium aluminum hydride. What is the function of lithium aluminum hydride? That is a famous reducing agent, and especially it is used to reduce the carboxylic acid. When it is allowed to react with the carboxylic acid, it reduces the carboxylic acid into alcohol. I mean primary alcohol. So to form a compound, a product J, here is J. This has become J. What happened when NaOH is added to the separate sample of tartaric acid and J? So what is going to happen? NaOH, it is adding to the tartaric acid, and in J separately, both tartaric acid and J will react. No, only acid will react with the sodium hydroxide. In J, now there are all four alcoholic group. Alcohol never react with NaOH, aqueous NaOH. So only tartaric acid will react, J will not react, and again not. B is the correct option. Question number 33. Citric acid can be converted into tricarbonylic acid in two stages. Intermediate Q is formed. Here is a citric acid, and here is tricarbonylic acid. So what is the difference between the last and the final? The basic difference is there is missing of OH group over here, and there is one hydrogen atom instead of OH group. So what is happening? What is Q basically? I mean, there is removal of OH group. How can we remove OH group from an inorganic compound? We can remove OH group by dehydration. So by making dehydration, we can remove hydrogen from one carbon or from either its carbon, and OH from here. OH, H, OH, H. So any one of these carbon can lose hydrogen, one hydrogen, and one OH, and there is the formation of double bond. So the Q is basically the most probably the Q is having carbon-carbon double bond in its chain, and rest of the acidic groups are over here, and hydrogens are again over here. One hydrogen and no hydrogen, two hydrogen over here. The question is, which reagent are needed for each stage? In stage 1, there is the dehydration, so we need concentrated sulfuric acid. A or B may be the correct options. In stage 2, double bond is going to be changed into single bond. I mean, we are going to add hydrogen over here, as you have seen that. So we need hydrogen and nickel, and lithium aluminum hydride cannot add hydrogen across carbon-carbon double bond. So A is the correct option. Question number 34. Structural and stereoisomer should be considered when answering this question. P has a molecular formula C5H10O. P produces an orange precipitate with 2,4-DNPH. I mean, it may be an aldehyde. It may be a ketone. It may be an aldehyde or it may be a ketone. How many isomeric structure does P have? 5, 6, 7, 8. I mean 5 to 8. Your answer, minimum answer should be 5, maximum can be 8 and so on. First of all, I'm going to make all the structure and then I'm going to check the stereoisomerism as well. As you have seen that there are 5 carbons. So first of all, I'm going to write the structure of 5 carbons. Due to 5 carbons, how many structures are possible? First of all, I'm going to write the for 5 carbon skeleton formula. This is the state chain 5 carbon, and the next formula that is possible with the 5 carbon with 1 branch. Next skeleton formula is possible with 2 branches with 2 methyl group, you can say. So there are basically 3 different skeletons with respect to 5 carbon. Let's suppose this, the ending carbon, this corner carbon may be having the aldehyde group. Yes, it is true. Then next carbon maybe can form or maybe in form of ketone. Yes, it is true. That is 2-on. The third carbon can also be in form of ketone. It can constitute a ketone. Yes, it is true. And the next carbon is going to repeat over here. Next 2 carbon are going to give the similar option, aldehyde and ketone. So this normal chain, this state chain 5 chain hydrocarbon can make 3 compounds, 3 carbonyl compounds, 1 aldehyde, 2 ketones. Those gives positive test with 2,4 DNPH. So 3 isomers are lying over here. And in this case, if I'm writing over here CH2 and CH3, there is no possibility of, as you have seen that as a straight chain compound, there is no possibility of any stereoisomer. So no stereoisomers in this case. Come toward the next one. In this case, you can see that if I'm having aldehyde group over here, yes, it could be. Rest of the all carbon will be simple carbon. CH3, CH, CH2, and CH3. And you can notice that this carbon is a chiral carbon. So there is 1 chiral carbon. At this carbon, we cannot make any ketone. It's a tertiary carbon. Tertiary carbon never can make, ketone or aldehyde. This carbon can also make the aldehyde, very much similar as that of this one aldehyde. So there is no need to draw the second aldehyde group. This carbon can also make ketone. Yes, it is true. And this carbon can also make aldehyde. Yes, it is true. So aldehyde, ketones, and again aldehyde. So 3 structural isomers are again present, plus 1 stereoisomer is because of this carbon. If I'm having this aldehyde, so this aldehyde is having 1 chiral center. But if I'm having another aldehyde, this one, CH3, and here is CH, there is no any chiral center. So if the aldehyde group is present on this carbon, there is no chiral center. If keto group is present over here, if I'm going to change this carbon into keto group and I'm changing it back into CH3 group, so there is no chiral center. Only 1 chiral center is possible when you are having aldehyde group over here or over here. That is one and same thing. So 4 total isomers are possible in this 4 longest chain carbon chain, you can say. The last one is this one. I'm going to draw it over here once again. The last option of the 5 carbon arrangement is this one, with 2 branches or 2 methyl group. There is only 1 possibility, that is having aldehyde. Only aldehyde can be made on this skeleton on this backbone structure. So again, there is no chiral center, CH3, I mean, this carbon is not chiral. So one isomer is over here, 3, 3, 1, and maximum 8 is the answer, and D is the correct option, correct answer. Question number 35, two isomeric alcohol. Two isomeric alcohol, W and X, have molecular formula C4H9OH. W is oxidized to the carbonyl compound Y, which gives red precipitate with a failing solution. X is oxidized to the carboxylic to the carbonyl compound Z, which does not give a red precipitate with a failing solution. Which of W and X give yellow precipitate with aqueous alkaline iodine? The first one thing is 4 carbons are over here, and the two isomer both are having the same formula C4H9OH. One is W, other one is X. W is oxidized to give a compound Y, that is a carbonyl compound. Carbonyl compound mean either it is an aldehyde or ketone. The next one thing is it's going to give the red precipitate with filling solution, so it is an aldehyde. So 4 carbon alcohol, which is capable to give the aldehyde, is this one. CH3, 4 carbon alcohol that give aldehyde, this one, or it may be this one, 4 carbon alcohol that can give the aldehyde. I mean, these are the two aldehydes that can be made from the alcohol by changing alcoholic group into aldehyde group. They're the two possible options. Now come towards the Z. That is not giving any red precipitate with the filling solution. I mean, this Z is ketone. So the 4 carbon alcohol that can be made, the ketone, that is, once again, I'm going to write the 4 carbon over here, and you can mark ketone over here or over here. The next structure possible is this one, and this structure, that is isomer of 4 carbon, but it cannot give the ketone. It cannot give any sort of ketone. So only one ketone is possible, that is butane into CH3, CH2, and CH3. Only one ketone is possible. Only one alcohol is possible that is going to give the ketone, and that is this alcohol, CH3, CH2, CHOH, and CH3, that is a secondary alcohol or butane 2O. And yes, now the second step is which one, X and W and X, that is going to give the positive test by positive iodoform test, that is going to give the positive test with alkaline iodine, that is methyl ketone. So this methyl ketone can gives the positive test. These aldehydes cannot give iodoform test positive. They cannot react. They are not supposed to react with aqueous alkaline iodine. So only this one, only that is Z, basically, only Z can, I mean Z that is formed from the X. So only X can give this sort of reaction. So X only, Z is the correct option. X is going to fulfill the criteria, that is going to give the basically yellow precipitate with alkaline aqueous iodine. Question number 36. The ester ethyl butanoate can be hydrolyzed using excess dilute sodium hydroxide solution. Which substance is the product of this reaction? Ethyl butanoate. This is CH3, CH2O, C double bond O. Butanoate means 4 carbons should be there. CH3, CH2, and CH2. If I'm going to hydrolyze this bond, this linkage is broken down, and OH over here, H over here. And as we have going to use sodium hydroxide, so there will be the formation of salt, ONA, and this portion will remain unchanged. So we are going to have this one compound plus this one. Let's see what are the option. Which substance is the product of this reaction? 1, 2, 3, 4 carbon salt. I mean 1, 2, 3, 4 carbon salt. The salt of butanoic acid, sodium butanoate. Yes, this one having the same common option. So A is the correct option. A is the correct option. Question number 37. An aqueous solution containing 4 gram of carboxylic acid Q. When this solution reacts with an excess of magnesium, 380 centimeter cube of the gas is produced, measured at STP. STP, you can see in the data booklet. What is STP? STP is the temperature at which 1 mole of a gas is equal to 22.4 dm cube. This is the molar volume at STP. 1 mole of a gas is having 22.4 dm cube volume at that temperature, that is basically 273 Kelvin, I mean 0 degrees Celsius and 101 kilopascal. So this time I'm using STP formula. This one. Basically, 1 mole is equal to 22.4 dm cube at STP. So we are having hydrogen gas. I mean, whenever magnesium is allowed to react with any carboxylic acid, with unknown chain of carboxylic acid, I mean, I'm going to make, generally speaking, I'm drawing a line over here. COOH goes to, there is a salt of magnesium acid twice and hydrogen gas is formed. So 2 mole of this monoprotic acid is required for the balancing the equation. So this is the balancing equation. So 1 mole of hydrogen is formed with respect to 2 mole of carboxylic acid with respect to 1 mole of magnesium metal. So first of all, I'm going to change this centimeter cube into moles. I mean, what is the answer in dm cube? 380 centimeter cube is equal to 380 divided by 1000 dm cube. That is 0.38 dm cube. We know that 22.4 dm cube is equal to 1 mole. 0.38 dm cube will be equal to x moles. So, and the answer is 0.0169, I mean 7 moles. So, this is the mole of hydrogen. Now, he is saying what is the formula? A relative formula of the Q. Basically, this time we are going to find the moles of acid. We are having the mass of acid. This time we are going to find the mole of acid. From the balanced chemical equation, 1 mole of hydrogen is equal to double mole of acid. 1 mole of hydrogen required double mole of acid to be formed. So, I mean, 1 mole of hydrogen is equal to 2 mole of acidic group. And if 0.017 is over here, how much mole of acid will be required multiplied by 2? I mean, that is equal to 0.034, you can say, moles. And now I'm going to apply the formula. Mole is equal to mass over mR. So mole is equal to 0.034. Mass is 4 gram, that is given in the question over here, and divided by mR. So mR is equal to 4 divided by 0.034. And the answer is 117.64. So B is the correct option. B is the correct option. Question number 38. The IR spectrum of the organic compound is shown over here. Once again, the basic method, you can say, once again, I'm going to cut this molecule into this graph into 2 portions. I'm going to cut this graph into 2 portions. And now I'm going to check the basic strong peaks, strong signals over here you can say, and this signal belongs to C double bond O. C double bond O, C double bond O, it may be amide, carbonyl, and ester you can say, and so on. So what is the range? 1700 range, and it may be any of the C double bond O amide and so on. Which compound could be this spectrum? In this case, you can see that this molecule is having C double bond O, yes, but it is also having OH bond. There is no any peak of OH bond in this region. Here is the peak of OH bond, and there is no any OH bond peak, so it cannot be an acid, it cannot be an alcohol. Again, it is having OH group. There is no any peak of OH group, and there must be the peak of C double bond O. So there is no C double bond O, and OH peak is not present in the spectrum. So B is quite incorrect. In case of C, C double bond O, and I mean it's a ketone. Yes, it is having C double bond O, and yes, it could be C may be the correct option. However, let me check the D. D is having C double bond O as well as it is having OH group. OH group is missing in the spectrum. C double bond O is indicated in the spectrum. So C is the correct option. Question number 39. The cyclohexene 1,4-diene is treated with a solution of bromine in tetrachloromethane. I mean, this is an inorganic solvent. So solvent is not going to participate. Solvent is not going to change the nature of the product. Whenever we are going to add Br2, there are two double bonds. So each bond is broken down every time in the dark, and Br, each double bond is broken down, and there's formation of Br group, and so on. So very easy. B is the correct option. B is the correct option. The last one question number 40. 2-methyl-butene is reacted with hot concentrated aqueous acidified potassium manganate 7 solution. I am going to draw the structure, going to write the structure of this molecule. 2-methyl-butene, but, and this is 2-ene, and this is 2-methyl. So this is methyl, and HCH3. If I'm going to apply this condition, concentrated, acidified, and heat, then there is the breakage of both bonds. I mean, carbon-carbon double bond is broken down, molecule changes into two parts. One is having this aldehyde. Finally, this aldehyde is going to change itself into OH group, I mean carboxylic group. Second one, again, where you are going to break the bond, when the bond is, where you have broken the bond, and this carbon is get oxygen, is going to have, this carbon is going to have oxygen. So the both immediate carbon, where you are going to break the bond, they are going to have one oxygen, and this is the ketone. It cannot be further oxidized. This is the aldehyde. It can be oxidized into carboxylic acid. So one is the carboxylic acid finally, and one is the ketone, ethanoic acid and propanone. Ethanoic acid and propanone. B is the correct option. That's all about today. Please subscribe my channel, hit the bell icon, and share it with your friend. Thank you very much. Have a nice day.